The morning frost still clung to the muddy ground when Oberst Friedrich Weber stepped past the coiled barbed wire into the American prisoner of war compound near the Rhine. It was March 23rd, 1945. Behind him, the river flowed with the same indifference it had shown for centuries, but everything else had changed. Weber had spent 3 years designing fuel systems for the Wehrmacht's panzer divisions. Now, after his capture near Remagen, he found himself assigned to a work detail helping American engineers sort captured German materiel. What he would see in the next 72 hours would shatter everything he thought he knew about why Germany was losing the war. The American supply dump stretched as far as Weber could see. Mountains of crates, barrels stacked 20 high, jerry cans in endless rows. An American sergeant, barely old enough to shave, directed German prisoners to help organize ammunition shipments. Weber watched, calculating in his head. The ammunition in this one depot, just one of dozens he could see from his vantage point, exceeded everything his entire Panzer division had received in the last 4 months combined. For years, German propaganda had assured its people and soldiers that the war would be won through superior German engineering, tactical brilliance, and the indomitable will of the Wehrmacht. The panzers were unmatched. The Me-262 jet fighter would turn the tide. New U-boats with enhanced capabilities would strangle Allied supply lines. Victory required only holding out long enough for these technological marvels to shift the balance. But standing in that American supply depot, Friedrich Weber began to understand a more fundamental truth. Technology meant nothing without the fuel to power it, the ammunition to fire it, the spare parts to repair it, and most critically, the logistical infrastructure to deliver it all to the front lines. Germany had lost this war not in the laboratories of its finest engineers, but on the roads where trucks sat immobilized for lack of gasoline, in the rail yards where traffic jammed because there were no coal wagons, and in the factories that could produce tanks but could not deliver them to the units that needed them. This is not a story of battles. It is a story about oil drums and locomotives, about jerry cans and cargo ships, about the brutal arithmetic of industrial warfare. It is a story about the moment when Germany's most technically proficient minds finally confronted an uncomfortable reality. They had been solving the wrong problem entirely. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. To understand how Friedrich Weber arrived at this moment of clarity, we must first understand what German military planners believed about logistics at the war's beginning. In 1939, the German Wehrmacht had perfected a new form of warfare they called Blitzkrieg, lightning war. The concept was elegant. Concentrate overwhelming force at a single point, achieve rapid breakthrough, then exploit the breach with fast-moving mechanized units. The key was speed. Move so quickly that the enemy could not establish new defensive lines, outrun their ability to organize a coherent response. In Poland, this strategy worked brilliantly. The campaign lasted just 5 weeks. In Norway and Denmark, the Wehrmacht achieved victory in a matter of days. The conquest of France, which many expected to bog down into another 4-year trench war like the previous conflict, took only 6 weeks. Belgium fell in 18 days. The Netherlands surrendered in 5. These lightning campaigns shared a crucial characteristic. They were short. Poland's road network from the German border to Warsaw covered roughly 300 kilometers. France from the German border to Paris stretched about 500 kilometers. Even the Wehrmacht's aging logistics system could keep armies supplied over such distances for a few weeks. The trucks broke down, the rail lines became congested, the horses died. But it did not matter because the campaigns ended before the logistical system collapsed completely. German planners drew the wrong lesson from these successes. They concluded that their military doctrine was sound, that Blitzkrieg could win any war, that logistics was a secondary consideration. What they should have understood was that Blitzkrieg worked precisely because it was designed around Germany's limited logistical capabilities. The doctrine was not a strength, but an accommodation to weakness. The German military's relationship with logistics was fundamentally constrained by resources Germany simply did not have. Consider petroleum. In 1939, Germany produced virtually no crude oil within its borders. What it needed, it had to import or manufacture. The Romanian oil fields at Ploiești provided the largest natural source. Beyond that, Germany relied on synthetic fuel plants using the Fischer-Tropsch and Burgess processes to convert coal into gasoline and diesel. These synthetic plants were technological marvels, testimony to German chemical engineering prowess, but they could never produce enough. At the peak of production in March 1944, Germany's synthetic fuel plants produced 185,000 tons of aviation gasoline, 221,000 tons of motor fuel, and 168,000 tons of diesel fuel per month. This sounds impressive until you compare it to what was needed. A single Panzer division on the offensive could consume 40 tons of fuel per day. An army group with multiple Panzer divisions could burn through 1,500 tons of fuel daily. The numbers simply did not balance. Transportation presented an even more fundamental problem. The German military relied overwhelmingly on horses and rail transport. In 1943 of the 322 German divisions in service, only 52 were mechanized or armored. The rest moved on foot or horseback. The Wehrmacht actually employed more horses during the Second World War than during the First, typically over 1 million animals at any given time. German divisions had more veterinarians in uniform than medical doctors. This reliance on horses and railways meant German logistics could work reasonably well in Western Europe, where rail networks were dense and distances short. But it created insurmountable problems in Russia. The Eastern Front stretched over 2,500 kilometers from the Baltic to the Black Sea. Supply lines ran for 1,000 kilometers or more. The Soviet Union used a different rail gauge than Western Europe, requiring either conversion of track or transloading of supplies at transfer points. The Russians themselves destroyed much of their rail infrastructure as they retreated. Germany's Quartermaster General, Eduard Wagner, warned the planners of Operation Barbarossa, the invasion of the Soviet Union, that he could guarantee supply for forces only 300 miles or 500 kilometers from the railhead. Beyond that distance, the logistics system would break down. The planners ignored this warning. They assumed, as they had in France, that the campaign would be over quickly. The Red Army would collapse in 6 to 8 weeks. Logistics would not matter. They were catastrophically wrong. When the Wehrmacht rolled into the Soviet Union on June 22, 1941, it advanced with 3,000 tanks, over 7,000 artillery pieces, and more than 600,000 trucks and other vehicles. Within 6 months, over 100,000 of those trucks were destroyed or broken down beyond repair. 200,000 horses died, collapsed from exhaustion, starved, frozen in the Russian winter. The losses were staggering, but more importantly, they were irreplaceable. Germany's truck production in 1941 totaled just 75,000 vehicles. The losses on the Eastern Front alone exceeded this. Worse still, German industry produced dozens of different truck models, each requiring unique spare parts. This meant a maintenance nightmare. A repair company might have the engine gaskets for a Mercedes-Benz truck, but not for an Opel Blitz. It might have axles for a captured French Renault, but not for a Czech Tatra. The Germans drove eastward in a rolling museum of European automotive history, and as each truck broke down, the chances of finding the correct part diminished. The rail situation was even more dire. The Wehrmacht had requisitioned coal wagons for military use at the Eastern Front. These wagons, desperately needed back in Germany to transport coal to power plants and factories, sat idle at chaotic railheads in Russia, often simply pushed off the tracks to make room for the next train. By winter 1941, Germany faced a coal shortage not because there was no coal, but because there were no wagons to move it. The synthetic fuel plants, those technological marvels, required enormous amounts of coal to operate. Without coal, they could not produce fuel. Without fuel, trucks could not move supplies. Without supplies, the army could not advance. The Wehrmacht had created a logistical death spiral. Yet somehow Germany persevered through 1942 and into 1943. How? Through a combination of ruthless exploitation of occupied territories and the capture of enemy equipment. In France alone, Germany confiscated hundreds of thousands of trucks. These vehicles, built to no common standard and suffering from years of deferred maintenance, kept the Wehrmacht mobile despite its own industrial shortcomings. More grimly, Germany's logistics in the East were subsidized by starvation. The Hunger Plan, conceived before Barbarossa even began, deliberately redirected food from occupied Soviet territories to German troops and German civilians. Millions of Soviet citizens and prisoners of war starved to death as a direct result. This was not incidental cruelty, it was strategic calculation. Germany could not feed both its army and the conquered populations, so it chose the army. By 1944, even these desperate measures were failing. Allied bombing raids had begun to systematically target German synthetic fuel plants. In May 1944, the United States 8th Air Force could finally provide long-range fighter escorts deep into German territory. The Luftwaffe, already weakened by years of attrition and hampered by fuel shortages that prevented adequate training of new pilots, could not defend the fuel plants. Production collapsed. From that peak of 185,000 tons of aviation gasoline in March 1944, production fell to just 10,000 tons by February 1945, a decline of 94%. Without fuel, the Luftwaffe's aircraft sat grounded. The new Me-262 jets were technological masterpieces, but they could not fly without kerosene. The Panther and Tiger tanks, feared by Allied tankers for their thick armor and powerful guns, sat immobilized in depots, waiting for fuel that would never arrive. By the time Friedrich Weber was captured in March 1945, the Wehrmacht was running entirely on fumes. German units operated from one fuel delivery to the next, often altering planned operations simply to reduce fuel consumption. Tank crews learned to calculate exactly how far they could drive before the last drop of gasoline ran out. Artillery units rationed shells. Infantry divisions that had been partially mechanized in 1939 were back to using horse-drawn transport, when they could find horses that had not already been eaten. The Battle of the Bulge, Germany's last major offensive in the West, launched in December 1944, illustrated the desperation perfectly. Hitler gambled everything on a thrust through the Ardennes forest, aimed at capturing the Belgian port of Antwerp. The offensive plan required the German panzer divisions to capture American fuel depots along their route because Germany could not supply enough fuel for the entire operation. The attack would literally run on stolen American gasoline. For a few days, it seemed possible. The Germans achieved tactical surprise, scattered American frontline units, and advanced rapidly through snow-covered forests. Then the fuel ran out. Panzer divisions ground to a halt kilometers short of their objectives. Crews were forced to abandon their Tigers and Panthers not because they were destroyed, but simply because they could not move. Without mobility and without air cover, The Luftwaffe could not support the offensive due to fuel shortages. The German attack collapsed. The offensive consumed the last significant German armored reserves and left the Western Front virtually undefended. Weber knew these facts intellectually. He had lived through them professionally. As a fuel systems engineer, he had personally struggled to design more efficient fuel pumps, better fuel filters, systems to squeeze every last kilometer from each liter of gasoline. He had felt the frustration of creating perfect solutions to technical problems, only to see those solutions rendered irrelevant because the fuel never arrived in the first place. But knowledge and understanding are different things. Weber knew Germany lacked fuel. What he had not fully comprehended until his capture was what adequate logistics actually looked like. Standing in that American supply dump near the Rhine, watching American soldiers work with an almost casual abundance, he began to understand the true scale of Germany's defeat. The Americans were not more clever engineers. Weber doubted that sincerely. German technical education was superior. German industrial engineering was the envy of the world. But the Americans had something far more valuable than engineering brilliance. They had resources and, more importantly, they had the logistical system to move those resources from factories to frontline troops with stunning efficiency. Consider the simple jerry can. The Germans had invented this fuel container in the 1930s, a brilliant piece of design. 20 liters capacity, triple welded seams, internal air pocket to allow for fuel expansion, 2 handles so 2 men could carry a full can comfortably, or 1 man could carry 2 cans. The spout sealed perfectly. It was robust, reliable, efficient. When the British captured the first German jerry cans in North Africa, they immediately recognized the design's superiority and began producing copies. The Americans went further. They did not just copy the design. They produced jerry cans by the tens of millions. Weber learned from other prisoners that American factories turned out more jerrys, cans, in a single month than German industry had produced in the entire war. And unlike Germany, which struggled to transport those cans to where they were needed, the Americans delivered them in vast quantities to every theater of operation. Perfect engineering meant nothing if you could not manufacture and deliver the product at scale. This insight gnawed at Weber as he worked in the supply depot. He watched American truck convoys roll past in apparently endless lines. He learned that the Americans called it the Red Ball Express, dedicated truck routes that had hauled over 400,000 tons of critical supplies from Normandy to the advancing Allied armies between August and November 1944. Over 6,000 trucks, driving around the clock at reckless speeds, maintained supply lines stretched over 500 miles. The Wehrmacht had never managed anything remotely comparable. German truck production had peaked at about 200,000 vehicles in 1944. American production that same year exceeded 800,000. And while German trucks represented dozens of incompatible models, American production was largely standardized around a few key designs, especially the 2.5-ton truck universally called the Deuce and a Half. Parts were interchangeable. Maintenance was simple. The logistics of the logistics worked, but trucks were just the beginning. Weber's education in American logistics was about to move to an entirely different level. On his 3rd day in the prisoner compound, he was assigned to help process captured German materiel at a nearby depot. What he would see there, American cargo ships arriving at Antwerp, unloading vast quantities of supplies with casual efficiency, would complete his understanding of exactly what Germany had been fighting against. But trucks were just the beginning. Weber's education in American logistics was about to move to an entirely different level. On his 3rd day in the prisoner compound, He was assigned to help process captured German materiel at a nearby depot. What he would see there, American cargo ships arriving at Antwerp, unloading vast quantities of supplies with casual efficiency, would complete his understanding of exactly what Germany had been fighting against. The port of Antwerp had opened to Allied shipping in late November 1944, after weeks of bitter fighting to clear German defenders from the Scheldt estuary. The Belgian city possessed one of Europe's finest deep-water ports, with nearly 26 miles of quays served by 600 hydraulic and electric cranes. Before the war, Antwerp had ranked alongside Hamburg, Rotterdam, and New York as one of the world's great maritime hubs. The British 11th Armored Division had captured it nearly intact on September 4th, though German forces had denied access to the sea approaches for 2 more months. When the port finally opened, it transformed Allied logistics. Between November 1944 and April 1945, Antwerp would receive 2.5 million tons of supplies, critical materiel that made the Allied advance into Germany possible. The port could handle the largest cargo vessels afloat. Its quays maintained a minimum depth of 27 feet, and excellent road and rail connections radiated outward toward Belgium's interior and beyond. Weber found himself on a work detail unloading American equipment at one of the satellite depots near the port. The scale of what he witnessed defied comprehension. Liberty ships, those boxy, utilitarian cargo vessels, arrived in steady succession. Each one could carry 9,000 tons of supplies in its holds, with tanks and vehicles secured on deck. And they kept coming, day after day, ship after ship. The Americans had perfected a type of mass production that Germans had never imagined possible. The Liberty ships themselves were a case study in industrial efficiency. Before the war, shipbuilding had been a laborious craft. Building a single cargo vessel required 6 months or more. Then an American industrialist named Henry Kaiser had revolutionized the entire process. Kaiser had never built a ship in his life. He was a dam builder, a constructor of highways and bridges. But when the British government approached American shipyards seeking cargo vessels in 1940, Kaiser saw an opportunity to apply factory production techniques to shipbuilding. He broke down each ship into modular sections that could be prefabricated at different locations, then welded together at the shipyard. Previously, ships had been assembled from the keel upward by a single crew working for months. Kaiser's method allowed multiple crews to work simultaneously on different modules. Welding proved crucial. It replaced riveting, which required highly skilled workers who needed 6 months of training. A welding novice could become productive in 2 weeks. Each Liberty ship required about 50 miles of welding, but it could be done quickly and in some cases by machine. Because riveting required overlapping steel plates while welding did not, the welded construction also saved precious steel. The first Liberty ship required about 230 days to complete. Within 2 years, Kaiser's yards had reduced production time to an average of just 39 days. The record, built purely as a publicity stunt, was set by the Robert E. Peary, launched 4 days and 15.5 hours after her keel was laid. Between 1941 and 1945, American shipyards produced 2,710 Liberty ships. Kaiser's operations alone accounted for over 1,500 of them. This meant the Americans were building approximately 3 complete cargo ships every 2 days. Germany's entire merchant marine construction during the same period could not match what American yards accomplished in a single month. The mathematical implications were staggering. Each Liberty ship could carry as much cargo as 300 trucks. The Americans were adding the equivalent of 900 trucks worth of cargo capacity every single day. Weber had never seen anything like it. As he worked alongside other prisoners sorting crates and barrels, he calculated obsessively. 1 ship, 9,000 tons. He knew what 9,000 tons meant. That was more supplies than a German Panzer division received in a month, in one ship. And there were dozens more visible from where he stood, lined up waiting their turn at the quays. The cargo itself was equally bewildering. American rations came in standardized cans, stacked in perfect rows in weatherproof boxes. German field rations consisted of whatever the quartermasters could scrounge: tinned vegetables from occupied France, dried meat from the Netherlands, bread baked in field ovens. The quality varied wildly. The supply was unreliable. American soldiers, Weber learned, ate the same reasonably palatable food whether they were in Normandy or the Philippines, whether they had been fighting for 1 month or 2 years. Medical supplies filled entire warehouses: plasma, sulfa drugs, penicillin in vast quantities. German field hospitals had been running out of morphine by late 1944. Weber heard American medics complaining about minor supply hiccups that would have seemed like paradise to German medical personnel. A shipment of bandages arrived 3 days late. Unacceptable, apparently, by American standards. But it was the ammunition that truly revealed the disparity. Ammunition depots stretched for acres, artillery shells stacked in pyramids, mortar rounds by the tens of thousands, rifle cartridges measured not in millions but hundreds of millions. Weber learned that a single American division consumed approximately 750 tons of supplies daily during active operations. Multiply that by the divisions now advancing toward Germany, dozens of them, and the totals became incomprehensible. The Americans fired ammunition at a pace German gunners could not imagine. American artillery doctrine emphasized overwhelming firepower. When American infantry encountered resistance, they called for artillery support. The shells arrived within minutes. Batteries fired mission after mission, expending ammunition that German units would have hoarded desperately for weeks. Weber spoke with other German prisoners who had been captured on different fronts. Their stories were remarkably consistent. The Americans just kept shooting. They never seemed to run out of shells. When German positions returned fire, American counter-battery radar located the guns within seconds and smothered them with shells. It was not that American artillerymen were more skilled. Many German prisoners thought their own gunnery superior. But skill meant nothing when the Americans could fire 10 shells for every German round. The revelation that haunted Weber was simple but devastating. Germany had been trying to win a different war. German engineers had designed superior tanks. The Panther and Tiger were better armored, more heavily gunned than anything the Americans fielded. German machine guns fired faster, more reliably. German optics were superior. German infantry training was more rigorous. None of it mattered. The Americans did not need the best tank. They needed enough tanks, delivered to where they were needed, fueled adequately to fight. They did not need the most brilliant tactical maneuvers. They needed soldiers supplied well enough that they could sustain offensives for weeks without pause. Germany had optimized for quality. America had optimized for quantity at acceptable quality. And in industrial warfare, the latter won, always. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Weber was not alone in this realization. Throughout the prisoner compounds, German officers and technical specialists were having similar epiphanies. They discussed it endlessly, trying to understand how they had misjudged so completely. Some blamed Nazi propaganda, which had assured them that Germany's superior technology and fighting spirit would triumph. Others blamed Hitler's strategic decisions, the refusal to acknowledge logistical limits, the insistence on fighting on multiple fronts simultaneously, the diversion of resources to wonder weapons that could never be produced in sufficient quantity. But Weber, with his engineer's mind, saw the deeper problem. Germany had approached the war as a problem of design optimization. If they could build a better tank, a better aircraft, a better U-boat, They could overcome numerical disadvantages. This thinking was not entirely wrong. German weapons were often superior designs, but superior design meant nothing if the weapons could not be delivered to the troops who needed them, supplied with the fuel and ammunition to operate effectively, and replaced when destroyed or damaged. The Americans had understood something more fundamental. War was a logistical system. Every weapon was merely the final node in a vast network of production, transportation, and distribution. Optimizing any individual component was less important than optimizing the entire system's throughput. Consider the GMC CCKW truck, the 2.5-ton cargo vehicle Americans called the Deuce and a Half, or Jimmy. It was not a sophisticated vehicle. The design was based on pre-war civilian GMC trucks, modified for military use. It had a simple inline-six engine producing around 100 horsepower, 4-speed transmission, all-wheel drive, hydraulic brakes with vacuum assist, basic proven components. The CCKW was not as rugged as some German military trucks. It certainly was not as well engineered as the precision vehicles Mercedes-Benz or Opel built for the Wehrmacht. But GMC and Chevrolet together produced over 800,000 trucks during the war years. 570,000 of those were the CCKW model specifically. More importantly, the CCKW was standardized. Parts were interchangeable. Any mechanic could repair one with minimal training. When a CCKW broke down, replacement parts were readily available. American supply depots stocked tens of thousands of spare engines, transmissions, axles, wheels, and smaller components. Germany produced perhaps 200,000 trucks total during the same period, but those trucks represented dozens of incompatible designs from multiple manufacturers across occupied Europe. French Renaults required different parts than German Mercedes required different parts than Czech Tatras. Maintaining this hodgepodge fleet was a nightmare. When a truck broke down behind German lines, finding the correct replacement part was often impossible. Vehicles were cannibalized for parts. Trucks sat immobilized for lack of a single component. The Americans had also standardized their fuel. American trucks, tanks, and vehicles primarily ran on a limited number of gasoline and diesel types. Germany's vehicles required different fuel grades depending on the engine. Some required high-octane aviation fuel. Others ran on lower grades. This meant separate supply chains for different fuel types, multiplying logistical complexity. Weber's mental model of warfare was disintegrating. He had spent years focusing on making individual components better. More efficient fuel pumps, better filtration systems, optimized injection timing. He had succeeded too. The systems he designed worked beautifully in laboratory conditions. But he had never considered what happened when those perfect systems encountered the chaos of actual war, where supply convoys were bombed, where rail lines were cut, where the fuel he had optimized for simply never arrived at the front. The Americans had inverted the problem. Instead of designing perfect systems that required perfect logistics, they had designed adequate systems that could function within imperfect logistics. A Sherman tank was not as good as a Panther, but 5 Sherman tanks, all running, all supplied with fuel and ammunition, would beat one Panther every time, especially when the Panther sat immobilized for lack of gasoline. As March turned to April in 1945, Weber watched the daily arrival of supplies at Antwerp continue unabated. The port operated around the clock. Cranes lifted cargo from ships' holds in continuous operation. Trains departed eastward loaded with materiel. Truck convoys rolled out toward the front. The machinery of American logistics functioned with industrial precision. And then Weber learned something that shocked him even more profoundly than everything he had witnessed. The supplies arriving at Antwerp represented only a fraction of American industrial output. Much of American war production went to the Pacific. Theater, where the United States was simultaneously fighting Japan across thousands of miles of ocean. America was waging a two-ocean war and winning both. Additional American production went to Allied nations through Lend-Lease. The Soviet Union alone received over 400,000 American trucks. The British received tanks, aircraft, ships, and countless tons of supplies. America was not merely supplying its own military, but functioning as the arsenal for the entire Allied coalition. The numbers were staggering. American factories had produced over 300,000 aircraft during the war, over 89,000 tanks, over 2 million trucks. The statistics went on and on, each more overwhelming than the last. Germany's total war production, which had seemed impressive in absolute terms, was dwarfed by American output in every category. Weber finally understood why Germany had lost. Not because German soldiers lacked courage, not because German weapons were inferior. Often they were superior. Germany lost because the nation had attempted to fight an industrial war without an adequate industrial base or the logistical infrastructure to employ what industry it possessed effectively. The German war economy had prioritized building weapons over building the systems to supply those weapons. This was backwards. In modern warfare, weapons were useless without fuel, ammunition, replacement parts, and trained operators. You could build the most sophisticated tank in the world, but if it sat immobilized for lack of gasoline or broke down without spare parts available, it was merely an expensive sculpture. America had built the logistics first, then filled that logistical pipeline with weapons. The weapons were good enough. Not perfect, but adequate, and there were enough of them, delivered where needed, supplied properly to overwhelm any opposition. By April 1945, the outcome was no longer in doubt. American and Soviet forces were closing on Berlin from opposite directions. Germany's remaining military units were scattered, undersupplied, increasingly immobile. The wonder weapons Hitler had promised, jet fighters, V-2 rockets, new U-boat designs, appeared in small numbers but could not change the strategic situation. They arrived too late, in too few numbers, without the fuel or trained personnel to employ them effectively. Friedrich Weber spent his remaining months as a prisoner of war working at various American supply depots. The experience was profoundly educational in ways that no German military academy could have provided. He saw logistics from the inside, observed how the Americans managed the mundane but crucial details that determined military success. He noticed small things that revealed larger truths. American supply officers tracked every item with careful paperwork. They knew exactly what was in each warehouse, what was being shipped where, what was arriving when. This obsessive accounting seemed bureaucratic and tedious, but it meant supplies actually arrived where needed. German supply systems, by contrast, often relied on informal networks, personal relationships, and guesswork. Items disappeared into the chaos. Units ran short while supplies piled up elsewhere. The Americans also built redundancy into their systems. They overordered, overshipped, maintained excess inventory. To Weber's engineer's mind, this seemed wasteful, but he came to understand the wisdom of it. War was inherently unpredictable. Bombers sank cargo ships, trains derailed, warehouses burned. Having excess inventory meant operations could continue despite setbacks. Germany's just-in-time logistics, which worked adequately in peacetime, collapsed under wartime disruption. When the war in Europe officially ended on May 8, 1945, Weber was still working at an American depot near Brussels. He heard the news without surprise. He had known for months that Germany's defeat was inevitable. The only question had been timing. In the years that followed, as Germany struggled to rebuild from the devastation, Weber never returned to fuel systems engineering. His wartime experience had shown him that individual technical brilliance meant little within poorly designed systems. He became instead a logistics consultant, helping German companies rebuild their supply chains and distribution networks. He remained haunted by a single observation from his time in American captivity. The abundance he had witnessed at Antwerp and elsewhere was not merely a matter of resources. America had always possessed resources. What America had developed during the war years was something more subtle and more powerful: the organizational capacity to turn those resources into military capability at industrial scale. This was the lesson Germany's engineers and planners had failed to learn. Superior technology was not enough. Tactical brilliance was not enough. Even numerical superiority was not enough without the logistical systems to employ it effectively. The nation that could produce adequate equipment, deliver it where needed, keep it supplied and operational, and sustain these operations over time would prevail. Always. Decades later, historians would debate exactly when Germany's defeat became inevitable. Some pointed to Stalingrad in winter 1942, where an entire German army was encircled and destroyed. Others pointed to Normandy in June 1944, when the Allies established a permanent foothold in Western Europe. But Weber would have offered a different answer. Germany lost the war the moment it failed to develop the industrial and logistical systems necessary to sustain modern mechanized warfare. The battles merely revealed what the logistics had already determined. An army without fuel cannot advance, no matter how skilled its commanders. Tanks without ammunition are useless, no matter how thick their armor. Soldiers without food. Surrender, no matter how brave. The Americans had understood this intuitively. They had built an unprecedented logistical infrastructure: the Liberty ships, the trucks, the depots, the supply lines, and then filled that infrastructure with adequate weapons produced in overwhelming quantity. The result was a military machine that could absorb losses, sustain offensives, and grind down any opposition through sheer material superiority. This was the war Germany had actually been fighting, not a contest of engineering prowess or tactical ingenuity, but a test of industrial logistics. And in that competition, Germany had never stood a chance. The disparity was not close. It was not even a fair contest. America produced more trucks in a single year than Germany produced in the entire war. American shipyards launched more cargo capacity in a month than Germany possessed in total. Friedrich Weber understood, standing in that supply depot in March 1945, watching American soldiers work with casual efficiency amid mountains of materiel, that he had spent the war solving the wrong problems. He had optimized individual components while the system itself was failing. He had pursued technical perfection while the Americans had pursued logistical adequacy at massive scale. The Germans had brought refined instruments to a bludgeoning contest. They had crafted precision weapons for a war won by crude abundance. They had tried to compensate for industrial weakness with technical superiority, and learned, too late, that modern warfare punished such miscalculations with total defeat. Years later, Weber would describe his realization in simple terms. Germany had built race cars. America had built a fleet of delivery trucks. And in a war that stretched across continents, lasting years, demanding millions of tons of supplies delivered across thousands of miles, the delivery trucks had won. They always would. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.